So this is A-level modeling with rate of change. So this is differentiation chapter, but it's for A2. Okay. After a road accident, fuel is leaking from a tanker on a flat section of the motorway, forming a circle of thickness of 3 millimeters. Petrol is leaking at a steady rate of 0.0008 meters per second. So there's a conversion of units here for the measurements. Find in terms of pi the rate at which the radius of the circle of petrol is increasing at the instant when the radius has reached 6 meters. Okay, so we do need everything converted to meters here. So 3 millimeters is going to be 0.003 meters. Okay. So what we're going to start off with, you should always start off with what they're asking us to find and what's given to us. So what they're asking us to find here is the rate of change of radius. So dr over dt. Okay, that's what they're asking us to find. And what's given to us here is petrol is leaking at a rate of 0.0008. So that's our volume that's changing at a rate of that. So dV over dt is the volume of petrol here. So it's forming a sort of a circle, but if it has a thickness, it's a bit of like a cylinder. So dV over dt is given to us as 0.0008 meter cubed per second. Okay, so if we have dV over dt here, so then what we need here is dr over dV times dV over dt. So that's the chain rule, and the linking component is this. So we need to find the volume in terms of R, and then we need to differentiate it. Okay, so let's get that started. So the circle basically has a structure like this. So it's leaking something like this, and it has a thickness of something like that, and that's 0.003 meters, and the radius here is r. So the volume would be, it's a volume of a cylinder, so pi r squared h. So in this case it's pi r squared times 0.003. So dV over dr is going to be that times 2, so 0.006 pi r. Okay, so that's our linking component. So if we were to substitute everything that we have here, that's going to give us dr over dV is this is the opposite of what we have, so the inverse of it. So you have 1 over 0.006 pi r times, and then dV over dt is over here, which is 0.0008. And then if you simplify this, you should get that divided by that is actually quite nice, 2 over 15 pi r, and that's the answer. But what we need to do here is, that's dr over dt actually, so we need to calculate it when our radius is actually 6 meters. So what we need to do here is, there's a glitch in the system, so I'm going to write it here. So dr over dt, when r is equals to 6, okay, r is given to us as 6. What we have to do here is substitute r as 6 in. So that's going to be 2 over 15 pi times 6. So that's going to cancel out as 1 over, so that's 1 and that's 3, isn't it? So that's 45 pi. So that's the final answer. Okay, dr over dt is equals to 1 over 45 pi. Thank you for watching.